So iTeams is designed to provide teachers with the tools to develop inquiry-based lessons and the opportunities to develop a deep understanding of implementation of NGSS and Common Core through support from the team of faculty led by both San Francisco State and the Exploratorium. So this is different from other PDs. We're not developing curriculum here in this setting. Our providers are giving you the tools to help you develop things and to look at what inquiry-based lessons look like. As I know, a lot of us have been using the Scott Forsman science, and it's not very inquiry-based. It's very, we read it, there's some experiments, but it's not as deep as we want it to be. And so that's what we're hoping. We'll have more of those ideas for science, and then how to integrate the math and the engineering and technology with it. So some of the follow-up time, which is where you have time to collaborate with your colleagues or collaborate either, and that could be with colleagues at school or across districts. That remains to be seen how we want to have that done. That will be time where you'll start developing some of those lessons and lesson ideas. We will have a website up hopefully soon where you'll be able to take ideas that you found or have done and put them on the website to share. So we'll be sharing resources. So not everybody's in their own little isolation developing things in isolation. And so that's sort of the idea around what we're doing. The professional development from this summer is to help you give you some tools and strategies and to help you develop those kind of things. Okay? Is there any questions about that? Is that a little clearer? Or is it just still muddy? Okay, then I'm going to turn it over to Tati and Terry.
Actually,
Or
maybe at this point we should say something about the business or our classroom.
Yeah. So one of the things that's always a tension, and this was some of the comments that came up yesterday, is the issue of I want stuff that I could take directly into my classroom, and sometimes in professional development that doesn't happen. And so what we want to just put it out there that part of our goals obviously are things that you can take and use in your classroom, but there's also some other goals that we have, and one of them is to extend your own learning, to push your thinking and your understanding farther than that of your students, which I can sometimes be uncomfortable, but that is often a very common goal of professional development. The other goal is also to put you in the position of being a learner, right? And sometimes it's what it feels like for your students, just to kind of remind yourself of, oh yeah, this can be hard when I ask my kids to take a risk, or it can be challenging when it's 2:30 in the afternoon and I'm asking them. I have the unfortunate, schedule where that's when, algebra is at 2:30 in the afternoon or whatever. So just being
implementation of the NGSS is not really going to happen until likely 2017. And the anticipated recommendations for assessment also will come up around that time. And in 2017 and 2018, that's when the curriculum and the instructional materials are going to be adopted. So there is a long timeline. So, any questions on that? So just moving on. Another question that came up was, will the middle school science be taught by discipline or will it be integrated? So the State Board of Education was really expected to take and accept the integrated version. But when it came to the vote, they decided to ask that another model is suggested, an alternative plan is suggested because there was a lot of pushback from some schools and some teachers. And a lot of them were just concerned about being able to integrate the curriculum in a way that would support student learning. A lot of them recognize that, they're specialized in one discipline. They will need to have a lot of professional development in other disciplines to be able to integrate something. So in response to that, they decided to give an option. So it's going to be up to your individual school districts whether or not they're going to take an integrated approach or a discipline-based approach.
I know this is still a couple years out, but I see that the state's giving districts options, but when it comes time for publishers to develop curriculum material, do you think publishers will offer up material in both formats, or because if the school district goes down one road and puts a lot of energy into it and then finds there's no textbooks to support that approach at the end of that, then they need to start back over again.
So I understand, they will be closely following the plan, the framework, and all the meetings. So they will be probably getting a feel over time for what schools are, the amount of schools are adopting one versus the other. Eric, perhaps.
So judging from the math experience, this kind of thing, there would definitely be textbooks for each option. Probably too many textbooks, in the sense that some of them might not do a good job really writing to a second grade. They might just sort of label and reshuffle. But I'm sure there will be materials that you can point at and adopt.
Okay.
I just have a question about what other states are doing. Are other states also adopting both like this, or is California?
I'm looking earlier into California. I think there is both. They're picking up different ones depending on the state. I don't know.
Does the integrated curriculum affect the current AP model of this one?
I would probably say.
That's a really good question. My reflexive answer is no, that the College Board doesn't usually let other people affect the curriculum, but I don't really know the answer.
In math, it doesn't. They have an integrated model for their high school sequences. Algebra and geometry are not separated courses, but the two AP tests, so statistics and calculus, and they tend to be their own classes that follow after the integrated courses, and then specialized calculus or specialized statistics. So the answer to math is no. With that.
So I'm typing down the questions, and as we get more updates, we'll be able to, as we meet and as we convert back and bring more information to you. So if you have any more questions, you can just send them to me and I can add them to my list.
What about students? Students aren't in this picture, but if we have kids that move around, military kids, parents get reassigned, you go from an integrated approach to a non-integrated approach, where does that leave them?
I've heard that one already. But
This is actually, it's not just a middle school thing. So in math, right, there's now an integrated option for high school. And so that's really serious. I think I'd go back and forth.
All right. So then finally, I just want to mention something quickly about the dimensions of the next generation systems. We didn't really talk about it, so I just wanted to address it briefly. So the framework for the next generation science standards is based on 3 different dimensions. So dimension 1 is the scientific and engineering have 3 items, 8 actions or practices that we expect the students to engage in throughout their experience from K through 12. And I can give you a handout on that, posting it out on this that has more explanations if you'd like to look at it. It's just an easy 2-pager. And then we have a dimension 2, which is our cross-cutting concepts. And these are concepts that are common throughout the curriculum, no matter what science topic you're looking at. So these are great for you to utilize in connecting and helping students understand throughout the disciplines. And then we have dimension 3, which is the actual content. And these are the core ideas. And there are 4 disciplinary areas. And depending on the area, you're looking at either 2 or 4 main disciplinary core ideas. And these are in physical science, life science, urban space science, and engineering technology. And we will be exploring these things throughout the IT's experience. So there's no need to really worry about this right now, especially because the framework for this and how this is going to be implemented hasn't been established yet.
And so that's what I'm going to want to do.
You're correct.
Because not everyone got to, there's a bonus problem, which is a train problem. And not everyone got to that. And I sort of don't want to ruin it for people who haven't finished it, which would be everybody. But, you can catch me at the break if you want to talk about it in smaller groups, okay? Because it's a wonderful problem. But I don't want to ruin it for people who haven't finished it. And if you see somebody, tell me what you hold up what they're doing. Some people are getting a little bit obsessive about it. Okay, I guess it's supposed to be healthy. Okay, but we don't have time to do that. So instead what I want to do is I want to see a few of the different ways that we can handle the water problem. So this means I'm going to ask really brave people to come up to this and show off some of their ways of doing it. So, could I see some quiet hands, people who are brave enough to show a way of doing this problem? So far, I see no brave hands, people pointing at other people at their kids. I see 1 brave hand. I'm going to hold out for 3 brave hands. 1 brave hand, 2 brave hands, 3 brave hands. Okay. Mike, why don't you start off with the bravery? Are you going to show really brave hands? It's a team. Please come up Okay, everybody. Shannon, take it away. I would like quiet.
Hi, I'm here.
Hi, Brave Shannon.
I'm so used to listening.
You just show.
Except for my square is really bad. Don't tell anybody I can do it.
Just pause that for a minute.
So this square, I saw it as having 4 corners. So I pulled those corners out, and then I looked at the part that does not include those corners, which would be 10 minus those 2 corners. So I see that, and then I saw that this part in here would be 10 minus 2. And then I pulled out those 4 corners, so I said, okay, so I have those corners. And then I would have to add those to the 4 times this 10 minus 2, which is that remaining part of that side. And there's 1 there, which is 10 minus 2. And there's 1 here that is 10 minus 2. And then 10 minus 2. So we've got 1, 2, 3, 4 of those. So it would be 4 plus 4 times 10 minus 2, which would also work for n length of sides. So that no matter what the amount of side is, it's 20, it would be 20 minus those 2 corners on each one of those sides.
Okay. What do you think? Yep. It's helpful. This means I totally agree. This is what she's talking about. Yeah, and it's an analog device. Okay. Shannon, let's thank her.
we have different ways of looking at it. You're going to share the manipulative. I'll just do one.
Okay, great. Take it away.
This is how I first looked at it here. Here's the one with number 1. Then we'll get number 2. Okay, and I said to myself, well, I know there's 10 along this side, and 10 along this side. But then I got to chop off the ends of each one for the corresponding, if these are vertical and these are horizontal. Each horizontal has 2 less than here. So I said 10, 10, 8, 8, done. 10 plus 10, 8 plus 8, 36. And then I said, well, that is 2 times n plus 2 times n minus 2. And then I tested my work like I tell all my 4th graders to. 2 times 10 plus 2 times 10 minus 2. 2 times 10 is 20 plus 2 times 8. 20 plus 16 equals 36.
Okay, and then do you have a general
That's
form? There, I see, it's up there, right, the general form?
Yeah, the general form is 2n plus 2 times n minus 2.
All right. Let's thank Brave Colin. Does any other super brave person want to come and show different ways? So I think our plan is yes.
That's me?
Yeah.
You should show that. That's pretty cool.
Getting nervous. He's fine. I'm concerned about this one. Okay.
Okay, so we had a lot of formulas, but we had one that looked particularly complex, which we thought was fun. This is the same one that you just showed right here. And then we looked at the area and we said, well, you know, if you take the area and you take the square root of the area, it's always going to be 2 less than one of the sides. So the square root of the area plus 2 is equal to the length. And then if you just plug that into the formula that you just gave, it comes out, it looks really cool and complicated.
Yes.
It's not, but it's
I'm confused anyway.
instead of writing square root of the area plus 2. And it's the same thing. And yeah, if you figure it out, it works unless you make careless errors, which I did a few times. And I put my parentheses in the wrong place.
Right.
My house was a little bit,
That's right.
rusty.
My question is though, would that only work for a square, whereas what I just showed might work for a rectangle, all rectangles? Yours is specific to squares that are rectangles.
That's why it's square root.
Yes, I know. But I'm saying my students,
Apply in every case. He's got
maybe
it.
not.
Okay, so let us thank him. Ready to does anyone else have questions? Mike, come on up.
Oh, yeah, because they didn't really show that. So we did 4n minus 4, because if you did 4 times the length of the sides and then subtract out those 4 corner tiles so you don't double count them, you get your size.
I want to see someone who did it.
Oh, 8 times 8, that's what I meant. 8 times 8 is 64, so 64 is on the inside, and then if I subtract 64 from 100, then I get my outside, right?
Yeah, exactly.
quite have time to debrief, so sorry. And that back table, I tell you, they had a gorgeous table. They made color-coded snap cube diagrams with different borders. Yes, last
Here, as a carpenter in doing this, you also have to do the mortar in between the tiles. So adding that eighth of an inch or whatever, then it's a fun process.
That would be a good problem. Okay, so the things I want to reflect on that problem. So first of all, there are a lot of ways into the problem. So why do we do this? There are a lot of ways into it, because you can always count. Secondly, it gives people lots of ways to be creative and seeing ways to dissect the shape. It teaches practice for visualization. And to me, one of the big lessons is all of those things that people wrote, gave me as answers, all were equivalent to 4n minus 1, wasn't it?
Yes.
And so you can imagine a world where there are textbooks, and it says, in order to solve the border problem, remember the formula is 4 times n minus 1. And that would be right, wouldn't it? But it kind of misses everything. First of all of your formulas, well, there's a way to see it as 4 times n minus 1. But all the other formulas are really interesting. And all the ways you dissected it, that's the really interesting part about this model. So this is a model of the border problem and border situation. But it's not modeling. Modeling is the process by which you come to a model like this. And that means that you guessed around, you made diagrams, you tried out formulas, you realized some of them were wrong. And it's just like the marshmallow challenge. Like you prototype things, you iterate. So there's a lot of commonality between design, engineering, and mathematical modeling. And in the science standards, it all gets compressed into something like use mathematics. That's one of the practices. But buried in that is a lot of stuff that overlaps with the scientific practices.